Oh, I'm sorry. If you're finished with the computer, turn it in to Miss Brewer, all right? Okay. Hey, I wanted to try something new. What you gonna do? Okay, old school hip hop song. You guys don't know anything about it. Okay, so look, here's the question we're working on. For the function 0, 1, 1, -3, 2, -4, -4, 1, write the domain and range. All right, so if you guys in the peanut gallery want to help, you can help out. How can I figure out what the domain and range is? That was a good hop. All right, so if we remember, the domain, all the x values, range, y values. And when we talk about x and y, what are we talking about? Remember, we have x and we have y. The x told me left and right, the y told me up and down. Does that sound familiar? All right. I'm actually talking to people in the room. I'm not just talking to myself like I do in other videos. All right. So what we're going to do here, this is how I do it. And, I'm going to label all my x values, right? And then I'm going to label all my y values. And I do this so I don't get mixed up because I get mixed up a lot, as you know. All right. So my domain is going to be what? 1, oh, sorry, 0. The next one is 1, 2, -4, and we put those brackets around it. So that's my domain. And now let's do the range. So my range is all the y values. I'm gonna have my brackets. And so my first one is 1, -3, -4, and 1. Oh, you see I have 1 twice. I may not necessarily need to write it twice. So I'm just gonna erase the second one and have my values. Now, one thing you may want to pay attention to is sometimes you want to have the x and y values in order, like -4 is the smallest, 0 would be next, 1, 2, like that. But right now, I have my x's and my y's, my d's and my r's. This is my r. So I'm going to look on the list here, D1. And my D started with a 0. This doesn't have a 0. And okay, this one has a 0. So 1, 2. I don't have a 3 in my D column. This has 1, 2, 3. You see the 3 here? So, let's look over here. My D is 1, 0, 0, 1, 2, -4. That seems to work out so far. And my R is 1, -3, -4. 1, -3. I think I found my answer. I'm just going to check again. All right. Do you think this might work? You think that's the answer? That's because you've seen it already, right? That's how we figured out what the domain and range was. All right. So let me go to the next slide. Yep, that was it. Good job. Thumbs up. Okay. Next slide. All right. Read it for yourself just for a second and see if you can figure it out. All right. Just want to make sure you had a chance to see everything. How'd you figure that out? If function x equals 2x plus 1, what would the function look like once you substitute in a one-defined function of 1? This is, I kind of write down notes to remind myself, right? So if I see f of x, or function of x, this means y in my head. It means y. Remember, we have x, we have y. X is left and right, y is up and down. All right, so this kind of means y to me. And if I see f and there's a 3, then this means that the x That means x is 3. So I'm just using this as a note to remind myself. So if f of x or y equals 2 of x, 2x times plus 1, 2x plus 1, 2 times x plus 1, what would the function look like when you substitute 1? Okay, so now I'm going to say f of x equals 2x plus 1, and it says substitute a 1. So now I'm going to say f of x equals 2 times 1 plus 1. That's what it would kind of look like. It didn't say solve it. It says what would it look like. And so it doesn't look like that. That says 21 plus 1. That's out. That says 2x times 1, but actually we substituted 1 for x, so that's not it. That leaves us with, it looks just like what I wrote. Oof, okay, so now that I see that, I know that we have the right answer. Is this making sense? Okay, we'll do one more. And Princess, you already figured that out, didn't you? We already did it. Okay. Let me make sure I'm right. Thumbs up. All right. Okay. What is the slope of the line represented by 6x minus 5y equals 12? Let's do it the long way. We're looking for the slope. What is the slope? The slope is m, right? Right? Right. Okay, so I need to get this into slope-intercept form, because when I saw slope of the line, I realized that it wanted y equals mx plus b. We call that slope-intercept form. So 6x minus 5y equals 12. And I like the way you handle it. I'm going to do it your way. Okay? Okay. So what I want to do is I want to move this whole thing here because I want it to look like this. I want y by itself in front. So I'm going to subtract 6x on both sides. And that cancels out because 6x minus 6x leaves me with 5y equals, and I'm going to put the negative 6x first because I want the x first in this slope-intercept form, plus b. So my b is 12. All right. So now I need to get y by itself so it'll look just like this. So I'm going to divide. And why am I dividing? Because negative 5y is actually negative 5 times y. And you may remember that I used to do this. The opposite of plus is subtraction. The opposite of multiplication is division. All right. So I'm going to divide by negative 5. Make sure you add the negative sign on both sides. All right, so negative 5 divided by negative 5, that really becomes 1. So it cancels out 1. And now I have two negatives dividing. So two negatives, multiplication or division become positive. So now I have 6 over 5x and negative 12 divided by 5. I'm going to keep that as it is because we're looking for the slope. And the slope is right here. That's my slope. So now I need to find a slope that looks like that. Is it negative 6,5? There's no negative sign here, so that's not it. 6,5, 6 over 5. This looks to be good. I'm going to put a check mark for that one. When I look at that one, this is the inverse, or the not the inverse. It's the opposite. I don't leave that one. I don't like it. Don't like it. And this is a negative. I don't like it. I think the correct answer is that because it's asking for the slope. Okay, let's see if I'm right. Do you know I make mistakes? Is that right? I was right. Cool. Hey, guess what? Miss Brewer just taught us something new. Check this out. You need to simplify this completely, right? And let's say you didn't know how to factor, right? You don't know how to factor. Or you want to do it quickly and just get it done. All right, so watch this. We're going to go to a handy dandy Desmos. We go to the scientific calculator and we plugged in the square root of 20, right? We plugged in the square root of 20 and we see the numbers, right? So what you're going to do is you're just going to plug in the square root of 20, and that tells you that that should be the answer. So square root of 20, that's the answer. Square root of 20, this is the answer. And so now we tried the other options. They gave us 4 radical sine 5, but that's not the same. So I'll get rid of that. It gave us another option was 5 radical sine 2, or 5 times the square root of 2. That's not matching. It doesn't match that. Get rid of that. 2, 5. Oh, check this out. Same answer. So we know that 2 gave us the same answer as this. So this is the most simple form. This is the most simple form. Brewer's a genius, right? All right, let's stop this. Okay, here's the next question. What is the zeros or 0 for the graph below? With the graph shown. What is the 0? All right, so this can be very, very simple. When it's asking you what is the 0 for the graph, all they're asking is what is the x value? What's the x? Huh? What's the x? Let me show you what I mean. Let me show you what I mean. All right. The 0 of a function, look, here it is. Graphically, when we're dealing with a graph, the real 0 of a function is where the graph of the function crosses the x-axis. Where it crosses the x-axis. All right. The real 0 of a function is the x-intercept, or it might be plural, x-intercepts. So let's go back, all right? So what's the 0 for the graph? Where does it cross the x-axis? Here's our x. Here's our y. Where does it cross the x? Right here at -2, right? That's where it crosses. That's where it crosses, okay? So let's see. Yep, Gucci. FUBU. Same one. All right, let me move forward. Let us move forward. Ooh, this is a good one. This is a real good one. All right. So I see an N here. I see an N here. And here's an N. There's an N. Everywhere's an N. All right. So what we need to do to solve this equation is combine in like terms. Combine the like terms, which are the N's, and then solve for N. We need to combine all these N's and then solve for N. So let's see what that would look like, all right? That'll look like 10 plus 2n equals 8 and minus 2n plus 10. Well, the first thing that I see is I can combine these two like terms. This is the n family. I can combine 8n minus 2n, right? And that's going to give me, what, 6n? 8 minus 2. So now I have 10 plus 2n equals 6n plus 10. Now, what I want to do is have my variables on one side and my numbers on the other. So I want to have the variables on this side, and I want to have the numbers on this side, all right? So what variable are we using? Let's not use the v, we'll use the n. We want to have the n's on this side and the numbers on this side. So to do that, let's go ahead and let's subtract 6n from both sides, all right? 6n. I messed that up. That's a 6n. That's a 6n, all right? So that leaves me with 10 plus, actually, 2n minus 6n is going to give me negative 4n. So let's go ahead and just make that a negative sign, all right? Negative 4n. This 6n minus 6n cancels out, so that gives me 10. Okay? And now I have 10 minus 4n equals 10. So I need to get rid of 10 on both sides. So this is a positive 10. I'm going to do the inverse operation, the opposite. So 10 minus 10 leaves me with negative 4n equals. And on this side, 10 minus 10, right, leaves me with 0. So now I have negative 4n equals 0. Some of you are jumping ahead and saying that this is the answer. You might be right. Let's find out. I'm going to divide by negative 4 on both sides, right? And that cancels out. Negative 4 divided by negative 4 becomes a 1, really. So I don't have to write a 1 in algebra if it's in front of the variable. N equals 0 divided by negative 4 is going to give me 0. So my answer should be 0. Let's see. All right. I might be wrong. Yep, I'm right. There we go. Let's go to the next one. Oh, man. Speedy Boat Rentals charges $15 deposit fee plus $2 for each hour of use to rent a paddle boat. Write an equation for C, the total cost to rent the boat for H hours. Okay. So C equals, what's it, $15 deposit. So I'm going to start off the rip with $15 plus $2 per hour. So I'm going to say 2 and each hour, oh, it says H hours. H hours. So we don't know how many hours. I'm just going to say 2H. So the cost, the total cost equals $15 off the rip plus 2H. That would be the equation that I would write. All right, so which matches? H, well, no, we're not solving for H. Not looking for H. All right, oh, here's another H. We're not looking for H. So it's going to be between these two. All right, and C equals 15H. We're not talking about 15 hours. It was $15 deposit, not 15 hours. So it can't be this one. So this one says C equals $2 per hour, $2 per hour, plus the $15 I have to start off with, right? So my answer is this one. That's how we figured that out. Hopefully you came to the same conclusion. Let's see, am I right? Am I right? I'm right. I mess up a lot, so I have to check. I'm solving for B. Wow. This one is a challenge. I'm solving for B. Solving for B. Okay. So it says I need to solve for B. right here I see BH, which really means B times H. So the first thing I want to do is get rid of this 2 here. I just want B and H by themselves. So I'm going to multiply both sides by 2. Actually, it's 2 over 1. But I can just do both sides by 2, right? Right, right. Now this 2 cancels out this 2. And since it's a 1, I can just cancel the whole thing out. So now I have 2A equal B times H. Another way I can say it is B times H, or I can just say BH. I could say just BH, but BH is really B times H. All right? BH is really B times H. Okay, so since it's B times H, how do I get rid of H? How do I get rid of H? I'm going to divide both sides by H. So now I have 2A equals B times H. I'm going to divide both sides by H. This H cancels out. That leaves me with B on this side. So now I have 2A over H equals B. Now I need to find which, let me see, B, or I can also say B equals 2A over H. I could put it either way. And since I'm solving for B, let's just do it this way. Let's just have B first, all right? So that's the same thing. B equals 2A divided by H. All right, so B equals 2H divided by 8. No, I have H on the bottom, so it's not this one. B equals A. Okay, but 2H, that's wrong. That's not what I came up with, so it's not that one. All right, B equals H over 2. No, I don't have H on the top. B equals 2A over H. This is it. This is it. All right, so this is it. And let's see if I'm right. Let's see if I'm right. I'm going to hit the button. Oh, I was right. Good. Woo, I was scared for a second. Those type of questions throw me. Okay. Which of the following lines is parallel? Parallel. What does parallel mean? Well, parallel means it has the same slope. All right? Same slope. Parallel, the word set parallel means it has the same slope. So the graph here says y equals negative 6x plus 3. Now, which of the following lines is parallel, same slope, to the graph of y equals negative x plus 3, which is y equals negative 6. I'm going to go up. I'm going to go down. I'm going down. It's a negative sign. So I'm going down 6. I'm going to move over 1 plus 3. So my slope is negative 6x. My y-intercept is 3. Oh, and it goes to the point negative 1, 4. It goes through the point negative 1, 4. All right, well, let's do this. Let's do this. Let's minimize this. All right, good. So I have those. I'm going to go to my handy dandy Desmos, DES, my Desmos calculator, and I want to use the Desmos graphing calculator. I like that one. So I'm click here for Desmos graphing. All right, and let's see. I'm just going to move this over so I can see both of them at the same time. I may need to bring my calculator in a little bit. It's something that you can do to make sure you see both of them at the same time, okay? Now, I have every space here has a number, so I want to lock that. Let me lock that viewport. So every space, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I like it locked there. So let's say this says I have the point negative 1, 4. So what I'm going to do in here is put in -1, comma, 4, in parentheses, right? Then I'm going to click label. And that's where -1, 4 is. Now, it says that my slope, we already identified the slope. And we're looking for something that's parallel that has the same slope, right? So -6x, that means I'm going to go down 6 over 1. So from this point, let me go down 6. I'm going to go down 6. 1, 2, 3, 4, 5, 6 over 1. So this point here would be 0, -2. 0, -2. Okay, so I'll type in here 0, comma, -2 and label it. Is that what I came up with? I'm going to go down. Do it again. 1, 2, 3, 4, 5, 6, and over 1. 0, -2. Good. So I have my 2 points, all right? Now, let's get back here. This says, which line is parallel to y equals -6 plus 3? Okay, so let's figure this out. I'm going to come back here, and I'm going to type in y equals -6x plus 3, and goes through the point -1, 4. So this is the point that I wanted to go through. I wanted to go through -1, 4. I'm not sure why I put that up there. I didn't need that. -1, 4. I want my parallel line to go through -1, 4. All right? So I need to find out what line is parallel. Parallel means it has the same slope. So my slope is still going to be -6. -6x. And let's say I think that my slope is going to be at 1 plus 1. No, that's not. Is it going through? It's not going through -4, -1, 4. It's not going, this green line is not going through this dot. So I'm thinking maybe 2. Okay. Maybe 0. No. So -1. Close. -2. There we go. I have the same slope, -6x, -6 rather. -6 is my slope. It's the same slope, so it's parallel. And it's going through -2, and it goes through my point. So which of the following lines is parallel to the graph? It's parallel, same slope, and goes through the point -1, 4. It goes through the point -1, 4. I came up with y equals -6x minus 2. Y equals -6x minus 2. Okay, I was right. Yes. I made one step I didn't need to make, but that's how I solved that problem. Does that make sense? Does that make sense? Good. All right. Let's go to the next one. Okay. This one is trying to trick you. This one is trying to trick you. Well, it threw me when I first looked at it. I was like, what is all of this? But then I said to myself, I'm capable. I can work this out. All right. S equals pi r squared plus pi rl. The surface area of a cone. Okay, so that's the surface area of a cone. Okay, that's okay. All right. So if I wanted to measure a cone, I would use this equation. Okay. Solve for, it wants me to solve for L. It wants me to have L equals whatever the rest is. Okay. Okay. So I can do that. I can do that. Let's do it. I can do it. I can do it. All right. So I have currently S equals pi. My pi is going to be looking crazy. R square. You know what? Let me do this. Let me reduce the size. So S equals my pi R square. You see, I'm rewriting it because it helps me understand what I'm working with. And I want to solve for L. I want to solve for L, okay? So first thing I want to do is I want to get rid of this. I want to get it from this side of the equal sign. And I'm going to do that by subtracting, pi r square from both sides, okay? It's hard drawing this. All right, so this minus this, it'll give me what? S, let me go ahead and put my lines here. S minus pi r square equals, remember this cancels out because that's pi r square minus pi r square. I just deleted the whole thing, got rid of it. Leaves me with pi times L. Now, remember when we've talked about the inverse operations? The opposite of plus is minus. The opposite of multiplication is division, right? We've kind of talked about that before. Hopefully you remember. Well, pi times L is times. So what's the opposite? What's the opposite of multiplication? Division. So I'm going to divide by pi on both sides. Hopefully I'm doing this right. Okay? So that's going to leave me on this side with S I did that wrong. So I want to cut this part out. Let's see. L. So if I divide that, it's going to leave me with S minus R squared. Oh, that's what threw me off. I figured it out. There's supposed to be an R here. So I'm dividing by R. Okay, so that's going to give me S. I caught my mistake. Hopefully you caught it before I did. All right. That's going to leave me with S minus pi R squared divided by pi R, right? Equals L. There we go. I figured out my mistake. S minus pi R squared divided by pi R, because this is pi R squared, so it can't just automatically, I have to leave it like that. So which one is S minus pi R squared divided by pi R equals L? It's this one. Whew, that was hard. That was challenging, but you know what? As I said earlier, we got through it. And let's make sure I'm right. Oh, I already had the green button there. Okay, good stuff. And we'll do one more. What are the y and x intercepts on this graph? What are the the x and y intercepts on this graph? Okay. The x-intercept is here. So the x-intercept looks to be 5. And y-intercept is here. And that's 1, 2, 3, 4, 5. That's 5 too. Okay. So the x-intercept is going to be 5, 0. Right? Yeah. And my y-intercept is going to be 0, 5. Okay, so this is what I'm looking at. 5, 0, 0, 5. This starts with 0, 5, so it's not that one. This is 5, 0, 0. This looks good. 5, 0, 5, 0. Nope, that's not it. 0, 0, that's not it. Okay, we found our answer. We found our answer. And we found that one in a lot shorter time. Whew, a lot shorter time. A lot shorter. Okay. So let's make sure I'm right, because I make mistakes. Yes, that was it. And look, that's what we're doing. Hopefully that 20 minutes will prepare you for, this final exam we have coming up. So good luck on the test. Do your best. It's corny. I know. Knock it out.